and I'm going to be talking to you a little bit about one-line A/B tests in Django. There's an old maths joke that this is a one-line proof, as long as we start sufficiently far to the left, and there's a sense in which that's going to be true of these as well. So I guess I'm going to very briefly introduce myself. My PhD was on human memory and forgetting. I put people in brain scanners to see how their brains change as a result of learning and to predict whether they would remember something in future or not. I actually scanned myself. I was disappointed to find my brain was smaller than I had hoped. And after that, I teamed up with Ed Cook, who is a grand master of memory. Together, we attempted to blend the very best ideas from the art and science of memory to help people learn up to 10 times faster than you would have believed possible. And it really works for everything from vocabulary in languages like Chinese to facts in history and geography to tropical fish or Morse code. And I urge you to check it out if you're so minded. And along the way, as the CTO, we ran lots and lots and lots of A/B tests in an attempt to try and optimize everything from the sign-up flow to the emails that we sent out to the kind of game design and the emotional messages and everything else. And we actually built our own internal A/B testing framework on which some of these snippets will be based. After that, I worked as a data scientist at The Guardian, helping build up their Redshift warehouse and kind of trying to distill a lot of the best practices about A/B testing for them. I should say one more thing, by the way. I don't really welcome, but I actually encourage interruptions. So if you feel the urge to contribute or have a question or a suggestion, then just kind of make a noise like a startled Mustang, and I will know that you have something you'd like to say. So definitely go for it. It'd be more fun if it's interactive, I think. So quick questions. Hands up if you have ever run an A/B test. OK, great. Hands up if you, in fact, know what an A/B test is. OK, great. And I guess hands up if you've used Django. Great. So I will kind of race through the things that will hopefully be obvious to most of you, because that's no fun to dwell on them. OK, so what's an A/B test? For me, the core idea is that when you're in the process of making lots and lots of decisions, whatever your product or your thing that you are offering the world, where you're not quite sure, is this going to make things better or worse? The biggest concern that you have is that having changed something, you've taken one step forward and 2 steps back. And I feel pretty confident that this is true of almost everything. If it's not obvious whether you're taking a step forward or back, you're probably tackling something almost easier than, well, anyway, I think most people suffer this problem where they're concerned that they might be making things worse as well as or instead of being better. So in some sense, an A/B test is the application of the scientific method to product design, where what we do is we say, OK, we're about to mess with things. We're going to make sure that some people see the old version of things, some people see the new version of things, and then we have a way of measuring, did we make them, which group's happier? Is the old version better or the old version worse? Do people come back more often, spend more money, report greater levels of satisfaction, sign up as a higher proportion with the new version than the old version? Does this make sense so far? I'm going to nod on your behalves. OK. So that's what an A/B test is. And I know that there was a talk yesterday, and I'm going to come to some of the kind of ways in which what I'm going to say might be both kind of relevant and complementary to what he said. So why run A/B tests? I think in some sense we know, but let's just talk it through. So opinions are like assholes. Everyone's got one, and everyone thinks everyone else's stinks. In other words, we have this problem where we're trying to make decisions, and we're like, well, I'm right, and yet you persist in having this opinion that is contrary to mine. Like, how do we adjudicate? Now, it may be that I get paid more, or I hired you, and therefore I win, but I might not, in fact, turn out to be right. So what would be more interesting would be if we can find a way to say, OK, let's try your version, let's try my version, and let's see what the users like best. And one of the main advantages, of course, of this, besides that you inexorably, monotonically improve, the other thing is, in some sense, it takes a lot of the emotional sting out of whose decision ended up getting implemented. So in some ways, it can be great for depersonalizing these debates. Okay, this, by the way, has nothing to do with the talk, but I just thought it was funny. If opinions are like assholes, I work with a lot of opinions. Anyway, moving on. So, the second reason that A/B tests are important is because, so let's say we're at The Guardian. I'm a designer. And I have determined that we need to change the font, that this is like the most critical change that needs to happen. And so today, we roll out a change where the font moves from whatever, Times New Roman to Helvetica. And I check the readership tomorrow, and I find that it's gone up by 50%. So naturally, I request a very large pay rise. Now that seems reasonable until you think, well, actually it turns out The Guardian just broke the Edward Snowden NSA story yesterday, this evening, and so that's what drove the surge in traffic. Now, if we run an A/B test where half the users got the old font and half the users got the new font, then both of them would show that surge in traffic. And by just looking at the difference between them, we'd be controlling for that sort of environmental factor. Does that make sense? OK. So I know we've got lots of scientists in the room, so maybe that's kind of obvious, but it's important. And it means that a lot of the hard stuff becomes about how you set up the right controls. But anyway, I think the final point I want to make is that there are many ways in which the brain learns. One of them is called error-driven learning. And the basic idea is this. I'm going to predict what I think is going to happen. If I'm right, great. I don't really have to do much learning. However, if I predicted that this was going to happen and something else happens, that difference between my expectation and what resulted is a sign that I need to update, improve, change my model of the world. In other words, I need to learn somehow so that next time I'm more likely to be right. Now, if you don't have that feedback, if all you ever do is act and you never find out whether you did a good job or a bad job, whether the world got better or got worse, then if you don't have that feedback, you don't know whether or not to change your model. In other words, the fact that I've changed the fonts a few times in The Guardian, I think I'm doing a great job, actually, I might not be making the blindest bit of difference. I might even be making it worse, and I won't know because somebody else is doing something that's sending the traffic up. Or maybe just web traffic is increasing year on year. So in other words, only by running an A/B test where we've controlled for all that external stuff can you really be honestly confident that you have improved things. It's a sort of, until you've made 100 changes and realize you still don't know whether you've done it better or worse, you won't really be gripped with the same paralysis that I started to feel without being scientific about things. OK. So it enables you to improve your intuitions. Over time, by getting feedback, you're like, that worked, that didn't. Interesting. OK, a minor preface. So I think Martin gave a talk yesterday, which I was totally unable to make, unfortunately. But my understanding is that he talks about some of the really important things that you need to bear in mind in terms of the statistical power and not peaking at your experiment multiple times while you're running it. And we'll touch on those issues a bit. In some sense, I'm going to do something I feel a little bit awkward about, which is I'm going to say sometimes those things are critical. Sometimes you can think about the 80-20 a little bit. And so a lot of this talk is going to be about how can we make pragmatic decisions, and as long as we're a bit careful, still be fairly confident without worrying too much about the stats. And I wrote scientific software for years, so I do care about that. But there's a sort of time and a place for making these trade-offs. So I'm going to be talking about low-hanging fruit stuff. I'm going to be suggesting that what you really want to do is look for big effects, where it's really clear that you've made things better or worse. So definitely I'm inviting questions about that stuff, but also kind of heading them off and saying, this is about the low-hanging fruit. This is about the most practical kind of decision-making. OK, so let's talk a tiny bit about code. In a sense, this is the one-line A/B test I was talking about, and I think the more curmudgeonly amongst you might point out that it's not exactly one line. So what you want to be able to do is say, OK, I'm going to run an A/B test on this user. So imagine they've just come to your website, and you're trying to decide, should I show them the green button, or should I show them the red button? Sounds kind of trivial, but you can imagine that it could be a much more interesting change, right? So the three arguments it takes are the user, the name of the experiment. So this is experiment 37. It's always important you give it some kind of unique ID or blah, blah, blah. And we're going to give it a label so that we can remember what it is later. This is the experiment about whether or not it's given the red or the green buy button. So far, so good. And then this is, in some sense, the only sort of vaguely contentious bit, is we're going to say, OK, in this experiment, there are two conditions. There's red or there's green. Now, you might want to label them differently. Maybe currently the button is red, so you might want to label this red control or something, green experimental condition, to reflect the fact that one is the current state of affairs and one is the new. Key point is we're feeding in, as arguments, these are the two conditions that I want to choose between. Then you can simply say, OK, well, if my magic function told me this person is in the red group, great, show them a red button. If my magic function told me this person is in the green group, show them the green button. And this bit of code should never run. It would be a bug in our AB function if it ever does, because it's supposed to only return red or green. Any questions so far? OK, great. So there are many ways of sort of defining this experiment model. This is what we ended up using for our internal framework, and it's kind of the simplest possible thing that works, and it's also designed to be fast. So we have an experiment table, and even if you don't know Django, hopefully if you know any SQL, this should be pretty straightforward, where we're saying, OK, the experiment has a name. If you remember before, it was E37, red versus green buy button, or whatever. It has a creation date, so that you know when you initiated the experiment, so that you can order them, and the most recent experiments come at the top of the list. And then we're going to have an association table, experiment user, that says, many to many, this user is in this experiment. And there are obviously many users in each experiment. And in fact, each user can belong to multiple experiments simultaneously. You could be testing the red versus the green buy button, and also testing whether to send them an email 1 hour or 24 hours after sign up. Simultaneously, those experiments could be running, and the user could be in various buckets for each. So far, so good? OK. The experiment user table is also as simple as we can make it. So this is the one that says this user experiment. So we've got a foreign key to user. So Greg, whatever. Got a foreign key to the experiment. Experiment 37, red versus green button. And then the bucket is, at this point, it's just a string. Now, the bucket might be red or it might be green. That's how we set things up. We know when we created it, and we're saying that each user can only be in a given experiment once. Because you don't want to accidentally end up in this situation where I've been put in both the red and the green buckets of this experiment. At that point, you've definitely made a mess. I'm kind of sort of waiting for someone to ask me whether this should be a foreign key. Perhaps I'll just proceed until someone does. And so then our function is really straightforward. It just says, OK, you've told me that you're looking for experiment 37, which is about red and green buy buttons. Okie doke. Get me that experiment. If it doesn't already exist, create it. OK, so we've got this user. We've got this experiment. Get me the row that tells me what bucket that person is in. If that row doesn't exist, create it. And if we had to create it, i.e., if we haven't already assigned this user to that experiment, then we better make a decision about which bucket to put them in and update that row. So in a sense, this is as deliberately straightforward as possible. And the production code we built is more complicated, but not that much more complicated. And there are smarter things one can do, but I decided not to worry too much about race conditions and stuff like that, because in practice, they're unlikely to occur. And so what we're going to return is simply red or green. The reason to set it up like this is because, let's assume you're doing continuous deployment, so you're deploying many times a day. What you want to be able to do is deploy a change that says, where before all the buttons were red, we're suddenly going to be like, actually, we're making a decision, is it going to be red or green? and then simply commit this change to your code without having to do anything to the database. And then it will automatically kind of dynamically notice, oh, wait, all of a sudden, you're asking me about this experiment 37. I didn't know we were running an experiment. Well, I better create an experiment row, and I better start assigning people to it. So in other words, it means that the business of running an A/B test is as simple from the point of view of the programmer as just adding a line like that. Does that make sense? Right? Because what you want to be able to do, you want to get to the point where people are running A/B tests all the time, getting results, and then being like, OK, red's the way forward, shut this down, set bucket equals red. Job done, right? And only ever run this first branch of the code. You want that cycle of starting up an A/B test and getting to a conclusion to be as friction-free as possible.
A question. When you got to that point, do you then delete comment out of that code, or do you do some hack where it automatically allows it to have a boolean in the experiment that says answer is, or something?
I think it's a really good question. What we decided to do was say, well, we've got a history in Git saying that at some point we ran an experiment, so let's just delete it, set bucket to be red, and in a sense forget in the code that there ever was an A/B test. I'm not certain that's the right move. I think the critical thing is that every experiment needs a URL. So you can generate it as a slug from the experiment name or whatever. But every experiment needs a URL so that in 6 months' time, when someone new joins and you've left or whatever, and we're like, oh, I reckon we should make the buy button green. Someone's like, hang on, no, we A/B tested this. We did the red versus green thing, and I can't remember what we concluded, actually. And so you can go back, you can look at your list of experiments. That's why they're stored in the database. You can see that, oh, yes, those were the results that we had last time. So the critical thing is that you can always go back and see what the results were. You can, if you want to, reproduce them because you know exactly. You just have to search in your code base through your Git logs for experiment 37. And that's why you give each experiment a unique number or whatever. That's how we did it, because we actually used the same numbering system in our ticketing system. But I think I could imagine there'd be a case for doing it differently. The key point is just as long as you can reproduce it, as long as you can always go back and see what your results are, then you're in pretty good shape.
You're talking about results, but what are the results? How do you measure?
Yeah, thank you. So I wasn't planning to get too deep into the SQL because honestly, it just gets really hairy. And I've started to put this code in a GitHub repository, and I'll happily talk a bit more about that. But I think this would be my suggestion for if you're starting to implement A/B tests for the first time, this is how I would start. So basically what this is a graph of is saying, OK, let's say you've come to the site or the product or the iPhone app for the first time today. What proportion of people come back tomorrow? What proportion of people come back the day after that, and the day after that, and the day after that? This notion of retention is if you're only going to measure one thing, that's what I suggest you measure. Maybe actually I'd suggest money, which A/B test group leads to most money, but you could argue that both have their merits. Anyway, if we focus on retention for now, this is the graph that you want to produce. So in a sense, it doesn't matter what the experiment I'm talking about here is. Control is red, and the swap group is blue. So what we're seeing is that over time, the proportion of people coming back to the site is higher for the blue, i.e. for the experimental new group. And so we can think of this A/B test as being pretty successful. In order to be able to do this, what you'll really be able to say is, OK, I want to know that this user first came to the site on day 0. Did they come back on day 1? Did they come back on day 2? Did they come back on day 3? And then you want to be able to amalgamate that over users. So if people are excited, we can talk through how to do the SQL for that. And I can point you towards where I'm starting to put all this in GitHub. But I thought I'd kind of start with just a high level. Does that answer the question? OK. So this is the current repository where I've been putting code in. It's one of those things where I thought it was going to be really easy to open source stuff, because it started out as a very clean, nice Django app. But I guess over time, over a couple of years of usage, all of the sort of other code started to leak into it. So it's there, and there's lots and lots of code that you can use to build things on, but the tests and documentation are sort of still a work in progress. I've also put this presentation up in there under the presentations directory, so along with some notes and stuff, so you're welcome to go and have a look inside it. Okay. I guess I wanted to sort of move a little bit to talking about some of the pro tips, some of the things that I learned the hard way or by having long conversations with people who are much more experienced than me. The first thing that I think is really important is to measure the right things. If you're focusing on high-level stuff, whether it be money or retention, if you can make those things go up, you're in pretty good shape. If you're only going to measure one number and it's a consumer web or mobile app, the proportion of people that come back the day after they sign up is probably the single most important thing you can measure. It's important because it's near the top of the funnel, so there's lots of room to optimize it, and it's important because there's no way they're going to be coming back on day 30 if they didn't come back on day 1. Does that make sense? And one of the first things that you realize when you're trying to build, say, something that's growing really fast is that if you're pouring, you could have a fire hose and be pouring it into a bucket. If the bucket's leaking, if it's got a big hole in it, then you're never going to fill it up. And the same is true for your website. You could have pretty great viral growth, but if hardly anybody comes back the day after they signed up, then your churn is going to just kind of dribble away any progress you might be making. Does that make sense? Second thing is run on a subset of your users. So I'm assuming you have at least enough traffic that this is a feasible thing to attempt. If you're still really early, then I guess you just split it 50-50 or evenly between your experimental groups. But if you can, run it on a subset. That way, if you screw things up, the cost is pretty low. If your A/B test is catastrophic and that the new condition is just awful, then you've only annoyed like a tiny fraction of your user base. What that means, of course, is that it licenses you to be a bit more daring, to try things that are unlikely to work just in case they do. The talk yesterday was on false positives, on the concern that you might think you found this new thing that's better, but actually it's not. My biggest concern is that actually people don't bother running A/B tests at all, and that if they start to, they get discouraged because most of the results are going to be null results. Like, I really can't get over the fact that, and I've seen this in papers as well, 9 out of 10 A/B tests, basically it doesn't make the blindest bit of difference. Red button, green button, the main problem is your usability sucks, or your server keeps going down, or whatever. There's almost always, like, big things, and unless you're A/B testing exactly the right stuff, then most of the time it won't make the blindest bit of difference, which is really dispiriting. Anyway, one way you can get around that is by focusing your analysis on just the users that are most relevant. So if you're making a change to, I don't know, how fast the page loads, you might find that it's going to affect mobile users a lot, but web users don't really care because they're on a fast connection and they don't really notice the difference, right? So you may find that only by looking at a subset of users for whom the change is going to be most relevant, then you see the effect. Remember how I talked about error-driven learning? The idea that you make a prediction about the world, and then you see if you're right, and if you're not right, change the way you think about the world. That idea of making your prediction first and write it down is so important. It's important because it forces you to generate that prediction and to sort of see that discrepancy, and because it forces you to understand exactly why you're running the test and what you think will happen. That's, over time, how you become much better at making judgments about what's going to work and what's not. And then we talked briefly about this idea that each experiment should have a URL, however you choose to sort of implement that, whether it's even as simple as just a page in your internal wiki or whatever. Find a way to consolidate your results so that you can have a way of going back and seeing, okay, this is what we discovered in the past. There's a few things to avoid, and I think Martin talked about a lot of the more technical ones. I'm going to talk about some high-level ones. The first is not to get lost in the weeds. I remember having a conversation with one of our senior advisors. I'm like, oh, I'm worried about this, blah, blah, blah. So we're running a whole bunch of A/B tests on, headlines and like the color of the font. He's like, look, don't get lost in the weeds. Most of this stuff won't make any difference. Find the things that are really important and focus on those. So in other words, I think this fits with the statistical power point from yesterday. Look for big effect sizes. Unless you can really see that this new version is making a big difference, probably it's not that worth it. Now, if you're Zynga and you have sort of 700 billion people coming through your site every day, and you're looking for every single millimeter of advantage, it's a completely different game, and that's not what this talk is aimed at. But for most of us, what you're really trying to do is make a meaningful sort of sea change in user behavior. And if you're not noticing that, then it's basically a bust as far as the result is. Don't expect your A/B tests to succeed very often, and I'll come back to that in a second. And don't keep checking the results. Basically, you statistically invalidate things if you see how your A/B test is doing every day. Decide you're going to wait until 500 or 10,000 people have been through the experiment, and only then you're going to look at the results. Otherwise, by peaking, you really statistically invalidate them, and you can make it much more likely you'll see a spurious result. That is something we can go into, but I think in some sense that's all you need to know. Don't keep looking under the covers. Wait till it's finished cooking. So there's a few sanity checks, and I'm a big fan of sanity checks. I have a talk that I really like to give on like how to write programs that aren't wrong, which is basically a whole bunch of ways of checking that things aren't completely screwed up. So here's one way you can do that with an A/B test. Run an AA test. In other words, both buckets have a red button. If you see a difference between the red button and the red button, right? If the second red button appears to magically improve your revenue, you have a problem. You either don't have anywhere near enough statistical power, or more likely you've got a bug, right? So it's a really easy way to check that you aren't being misled. This is a particularly unpopular suggestion. Try making things worse and confirm that you have in fact made things worse. For instance, and I nearly had a fight with my co-founder over this, happy one, but a sort of fight. I artificially increased the loading time of the page by 5 seconds. So about 10% of our users were sort of sitting there for like 6 seconds waiting for the page to load and having a really crappy experience as a result. And the question I wanted to know was, like, how much does that affect things? Because if we lose everyone, then I should be really worrying about performance. If everybody loves what we're doing so much that they're kind of indifferent, or they're sort of busily planning whatever, then I shouldn't be worrying as much as I am about performance, right? In other words, make things worse. In so doing, determine the importance of that component. Because of course, in an ideal world, you'd make them better and see how much that improves things, but it's hard to magically wave a magic wand and say, make performance way better and see if people like it more. Again, it also tells you, if by making things a lot worse, you see no effect, you might be screwing up your measurement, your results plotting. Okay. I think this is the lesson that I still find hardest, and maybe, in a sense, if you only take one thing from this, perhaps this is the main thought. I thought writing the A/B testing framework was the key part. In fact, I kind of managed it in a couple of days, and I'm sure you could too. A couple of models, add some A/B testing, if this, and then plot the results. You can even sort of say, well, I'm not in any hurry, it doesn't have to be real time, it can email me at midnight, in which case it doesn't even have to be fast. The initial version I did ran a single query for sort of every single day, and you end up running 500 queries. So I was like, who cares? Let's not bother with the SQL. Let's just make it run and see how we go. So I had this initial implementation in a day or two, and I was feeling pretty smug. What I hadn't realized is that the software is the easy bit. Imagine the following conversation. Your designer, whose judgment you mostly trust, and who's been to design school and spends his entire time or her time thinking about the interface and the visuals and the experience, and you tell them, science says no. This new change is no good, right? It didn't make any difference. You labored on a site redesign for a month, and honestly, doesn't look like it made the blindest bit of difference. We were wasting our time. Let's not do any more redesigns, right? You can immediately imagine how that person is going to feel. You end up having discussions about, well, look, you know, I think you've got to just trust your human judgment sometimes, and A/B tests are a lot of work. You know, we want to add this big new feature that's going to change every single page slightly. Like, you really want me to A/B test all of that? It's going to take ages. It's going to mean I've got to have the old code running with the new code. I can't just do a straight migration. So the programmers are like, this is a colossal amount more work. You sort of squared the complexity of everything. Like, can't we just make the change? I just wrote all this new code, and you're telling me that actually if it doesn't make a difference, I'm going to have to throw away the code I just spent a week writing? Like, you can imagine how all of this stuff goes down. And you know, I think I was probably too forthright. I'd just come out of my PhD. I'd just spent like, you know, years of my life running psychology experiments. I was like, this is how the world should be. This is great. I can be scientific about everything. I don't have to worry about whether I'm right. I can just have an intuition, generate my hypothesis, run a test, and then I'll know. So all I'm warning you is that there is an enormous merit to this. It offers the promise of a sort of monotonic improvement. But it's not straightforward to build this into your team dynamics, into your sort of company culture. You have to have a kind of quite humble and scientific company ethos before this becomes as effective as it can be. I'm just warning you about that. OK, so I guess I wanted to keep this brief. I wanted to leave loads of time for questions. I love thinking about this stuff. I love living at the intersection of software engineering and kind of science and startups and products and strategy. So for me, there's very little I enjoy talking about more. And so if you ever want to brainstorm together, you're welcome to drop me a line, and I'll try and chat it over with you. And I guess I also consult on a lot of this stuff, too. I'm going to, so all of this is on the Abracadabra GitHub page. I don't know if that's a good name or not. So you're welcome to download this presentation. And I included the 4 things that I found most useful for thinking about A/B tests. So Eric Ries is the kind of evangelist for a lot of this kind of lean startup thinking. These 2 papers are great examples on why it's important, on how to implement this within a larger context, and to how to think about like dealing with experiments at colossal scale, where you're sort of Bing or Google, and you're building a massive A/B testing framework that can deal with dozens of A/B tests running at the same time and analyzing the data. And then Miller talks a lot about all the ways in which you can screw it up. But like I say, the main worry is that you never get around to actually doing it at all. So worrying about screwing it up, you're already quite a long way ahead of the game if that's your concern. So thank you very much for your attention.
You talked about obviously having control so that you're always checking whether it's in fact the fact that the site's released something else. But how do you deal with the phenomenon of newness? So suddenly your website looks new. Some people are keen on that because it's something new. Some people are like, oh, the site, you know, I don't like the change. How do you go about dealing with that? Do you do kind of A/B/C/D tests and look at which of the new ones works, or?
What we did was to restrict the analysis to people that signed up after the experiment started running. And that way you don't have that problem. It requires you to have a bit more data. It means you're throwing away the sort of effect on all the people that were already part of your site. And there might be reasons why you'd be worrying about what they think as well. But that way, at least, you're not having to think too hard about it.
So you don't ever do more than A/B, as it were? So you
No, sorry. I've definitely run A/B/C/D/E/F tests. Okay. But the key point is that
that would get rid of the newness problem, because all but one would be new. Sorry, they'd all be new but one.
I think what I was imagining was that if you only analyze the data for users that joined your sort of started using your product after the experiment started running, none of them know what it was like beforehand. So for them, in a sense, all of the buckets are new. Does that make sense?
So I meant more for other sites which don't have that luxury, because you're a new site and you really don't know that someone's new or old.
Well, I mean, I suppose one thing you can do is, so if you analyze the data for just the users that have joined after the experiment and you see that B is doing better than A, you can check whether that's also true for users that have been around for a while. And if it's different, then, OK, now you have to think a little bit harder about, OK, there's an interaction between the experiment conditions and the newness. And then maybe you can have a dialogue with your old users. And maybe part of the issue is you need to have a forum where they can complain, and you can have a community support manager who says, well, I know it's new, but you'll get used to it. Oh, OK, well, we'll add that feature back in. And then it becomes a dialogue rather than an imposition.
In my experience, analyzing significance for things like retention is quite easy. You mentioned that you also would advise to look at revenues, which are not normally distributed, and it's much harder to actually. And to analyze significance for revenues is much harder. Have you actually done things like that? Did you come across any papers?
Yeah, so I haven't done much work on revenue. I looked at it a little bit at The Guardian, but only very little bit. I guess the reason why analyzing revenue might make sense is if, I think eBay has an example where they did an A/B test that meant basically there were fewer items being sold, but more of them were high value. So you might look at a straightforward metric, and maybe you might see retention go slightly down, volume of transactions goes down, but overall revenue might increase. You could imagine doing things like at The Guardian, if you were to find ways of monetizing new users more heavily and monetize old users less heavily, for instance, that might make revenue go up, but retention go down, for instance. So I guess what I'm trying to say is they don't always perfectly correlate with one another. Brilliant. Thank you very much. Oh, OK. No, well, I guess we got one more, so feel free to scamper if you feel.
The problem with people advising using AA test, running AA test.
Yeah.
Like, let's create a new test and run it for next month or something, and it will be an AA test. What's the point if you can just sample the data randomly from historical data?
I mean, if nothing else, you're making sure that your A/B testing machinery is working. Right? Because if you see an effect for an AA test, it tells you either you're not doing you're not thinking about your statistics correctly, or that your machinery is not working for some reason. So that's, if nothing else, do it at the beginning, right? Think of it as a unit test that you occasionally run or something.
How big are the tests I mean, obviously it's hard to describe, but how big are the changes you're making, let's say to an interface? Because you can change minute things and technically be really scientific, but the effects you'll see are really small and you haven't got time. But if you change everything, then you maybe lose one new feature that's good because you've got another one that's bad. So can you give a kind of idea of how big a changes you're making to it?
Yeah, I think that's really hard. So the question is, should you make lots of little changes, or should you make one big change, and how do you sort of think about the spectrum in between? I guess to the extent that the big change, you kind of have to make it all at once because it affects all of the various interactions. Then it might make sense to make the big change and A/B test it as one thing. But if you can split it up into separate components that are in a sense independent or orthogonal, try and do that. Remember not to get lost in the weeds, right? So don't A/B test 1,000 million things, because unless you think any of them are going to make a big difference or a meaningful difference, whatever that means, then don't bother. And I guess, I think those are that's the balance you have to strike. I guess you could always try making one big change and then looking to see if there's a big effect, and if there is, trying to break it down and understand why. The concern is always the one step forward, two steps back. So if you make a big change and it makes no difference, you don't know for certain that you didn't make things better in some regards and worse in others. So the advantage of doing things in individual components is you maximize how much you're learning. You maximize how accurate the feedback your brain is getting is. And you might realize, oh, that's interesting. It was better in this regard and worse in that regard.